For centuries, the Sahara was seen as empty, hostile, and unusable. But beneath its burning sun lies enough energy to power the entire planet. Today, Africa is beginning to transform this desert into the largest renewable energy system Earth has ever seen. The Sahara Green Corridor. The Sahara Desert has long been defined by extremes. Endless sand dunes, brutal droughts, powerful sandstorms, and shimmering mirages stretching across lifeless land. Covering nearly 9 million square kilometers, the Sahara spans 10 countries and 3 time zones. If it were a nation, it would be one of the largest on Earth, bigger than Brazil and only slightly smaller than China. For generations, this vast region was viewed as a barrier to development. Today, it is being reimagined as one of humanity's greatest energy opportunities. The Sahara receives more direct sunlight than any other region on the planet. Global maps of annual sunshine hours reveal solar hotspots in parts of North America, South America, and Southern Africa, but none compare to North Africa. Large areas of the Sahara receive more than 3,600 hours of sunlight every year, with some regions exceeding 4,000 hours. That is nearly 4 times the annual sunlight received by countries like Germany. This extreme exposure is no accident. The desert lies almost directly along the Tropic of Cancer, meaning the sun remains high in the sky for most of the year. Clouds rarely form, allowing sunlight to reach the ground almost uninterrupted from sunrise to sunset. Each square meter of Saharan land absorbs between 3,000 and 4,000 kilowatt hours of solar energy annually. When these numbers are scaled up, the potential becomes staggering. More solar energy strikes the world's deserts in just a few hours than humanity consumes in an entire year. Even a small fraction of the Sahara, if used efficiently, could generate electricity on a continental scale. This idea has evolved into what is now known as the Sahara Green Corridor, a vision of turning relentless sunlight into a continuous belt of renewable energy stretching across North Africa. This corridor does not require covering the entire desert. Even modest solar zones, strategically placed, could power entire countries. Larger zones could meet the electricity demand of entire continents. At its theoretical limit, the Sahara could generate many times more energy than the world currently consumes, redefining how civilization produces and distributes power. Renewable assets the size of countries. What is being built across North Africa is not a collection of traditional power plants. These are renewable assets measured in land areas comparable to cities, regions, and even entire countries. Deserts and dry regions already host the world's largest solar facilities, and Africa is rapidly expanding this model at unprecedented scale. Morocco stands at the center of this transformation. The country has invested billions of dollars into solar energy, constructing one of the largest solar power complexes ever built. Spanning tens of square kilometers, the facility generates hundreds of megawatts of electricity and operates as core national infrastructure rather than an experimental project. This is only the beginning. Morocco plans to build multiple large solar installations across desert regions, with the goal of supplying a significant share of its national electricity demand from renewable sources. By 2030, more than half of the country's electricity is expected to come from solar and wind power, transforming Morocco from a fossil fuel importer into a renewable energy leader. Other North African nations are following similar paths. Algeria and Tunisia have announced multi-billion-dollar solar projects, while Egypt has rapidly expanded photovoltaic installations to meet growing demand. Across the region, solar energy is no longer a future ambition. It is a present-day necessity. 2 technologies dominate these developments. Concentrated solar power uses mirrors to focus sunlight, producing heat that can be stored and converted into electricity even after sunset. This provides built-in energy storage, but requires large land areas, complex mechanical systems, and significant water use. Photovoltaic solar panels convert sunlight directly into electricity using silicon-based cells. Over the past decade, this technology has become dramatically cheaper, more durable, and far easier to deploy at scale. As a result, modern African solar expansion increasingly favors photovoltaic systems, sometimes combined with storage or hybrid designs that balance reliability and cost. These installations can be expanded modularly, maintained more easily, and deployed across vast areas. At full build-out, solar zones across the Sahara rival the electricity output of entire nations, reshaping what energy infrastructure looks like in the 21st century. Continent-scale HVDC power lines. Generating massive amounts of electricity in the desert is only half the challenge. The true scale of this transformation lies in moving that power across Africa. This requires transmission infrastructure as ambitious as the solar fields themselves. High-voltage direct current transmission makes this possible. HVDC power lines can transport enormous amounts of electricity over thousands of kilometers with relatively low losses. This makes them ideal for connecting remote desert solar zones to cities, factories, and population centers. Africa is now laying the foundations for continent-scale HVDC corridors that function as electrical superhighways. These corridors are designed to link Saharan solar farms with coastal wind regions, industrial hubs, and major cities across the continent. Instead of isolated national grids, the long-term vision is a unified energy network capable of balancing supply across regions, climates, and seasons. Power generated in the desert can flow to where it is needed most, stabilizing grids and reducing energy shortages. Connections between North Africa and Europe also remain part of the broader vision. Morocco's short distance to Spain makes undersea power links technically feasible, allowing excess electricity to be exported when available. However, the priorities have shifted from earlier plans. Today, the emphasis is on domestic energy security first, strengthening local grids, supporting industrial growth, and reducing dependence on imported fossil fuels now take precedence. Exports are treated as surplus, not obligation. These transmission corridors represent more than engineering achievements. They are instruments of regional cooperation and long-term economic development. By linking renewable assets across borders, Africa is building an energy system designed to grow, adapt, and endure. Environmental and practical realities. Transforming the Sahara into a renewable energy powerhouse also presents serious environmental and logistical challenges. Large solar installations absorb significant amounts of heat, while only a small portion of incoming sunlight is converted into electricity. Most of it is released back into the atmosphere as heat. At extreme scale, this could influence regional climate patterns. Some climate models suggest that large solar deployments could increase rainfall over parts of the desert, potentially encouraging vegetation and biodiversity. While this may sound beneficial, it could also disrupt distant ecosystems. Saharan dust currently fertilizes the Amazon rainforest and supports Atlantic marine ecosystems. Large-scale changes to desert surfaces could reduce this dust flow, triggering unintended global consequences. Water availability is another major concern. Solar panels and mirrors must be cleaned regularly due to dust and sandstorms. Concentrated solar systems also require cooling for steam turbines. In regions already vulnerable to drought, water use must be carefully managed through advanced cooling technologies, recycling systems, or integration with desalination infrastructure. Logistics present additional obstacles. The Sahara is vast and sparsely populated, with limited roads and railways. Transporting equipment into remote regions requires massive investment before construction can even begin. This is why many projects focus on the desert's edges rather than its deepest interior. These challenges do not make large-scale solar impossible, but they demand careful planning and realistic scaling. A new global energy geography. What is emerging across North Africa is not a single megaproject, but an entirely new energy geography. Deserts are becoming infrastructure. Transmission lines are becoming economic lifelines. Renewable assets are being built at sizes once reserved for oil fields and gas basins. Africa is no longer positioned as a future energy consumer waiting for development. It is actively shaping itself into a renewable energy producer with global significance. The Sahara Green Corridor represents a shift in how humanity views barren land, sunlight, and energy itself. If this transformation continues, Africa will not only power its own industrial growth and urban expansion, but also help reshape the global energy system. Not through extraction or dependency, but through sunlight harnessed at continental scale. Africa is not just building solar plants. It is building the largest renewable energy system Earth has ever seen. If you found this video useful, like it, share it, and subscribe for more videos on energy and global projects.